Hello everyone. So in this episode, I'm going to discuss a little bit about serverless observability. Observability for your serverless application is really required if you're running a production workload in serverless. Particularly if you have some asynchronous workflows, observability really plays a major role when it comes to identifying problems and troubleshooting. So I think if you're already having a serverless application that runs production workloads, this episode will be helpful to you. And in fact, most of our production applications have some asynchronous workflows, right? So most of them are event driven. So they are not exactly request response based applications. We always wanted some event driven flows implemented in our application in order to make them easily scalable and reliable and so on. So there was a saying that if you don't have event driven workflows in your application, it could be a bug. So I hope you'll enjoy this episode and see you in the other side.
Alright guys, so the demo application that we are going to develop is an order processing system. Now in this application, users can send their order request to this API gateway post endpoint, and then the API gateway, which is serverless API, invoke the related lambda for that particular path. And this lambda, we call it, let's say, order receive lambda. The main purpose of this order receive lambda is to get that order details from the post body and then schedule that order in a SQS queue so that it will be later processed by this order process lambda. So by using this SQS queue, we are decoupling this end, the API gateway and this order receive lambda from the consumption part of it or the processing part of that order. So why we thought of using SQS queue is basically there'll be number of steps for processing an order. Maybe it could be first charging the customer. Now, if there are any problem with the charge, we have to handle that. And then maybe we have to check whether the delivery partners are available. So, I mean, there could be certain steps related to processing the order so that users do not have to wait until all those steps complete to get the confirmation that their order is failed or success. So what we did instead is that whenever we receive an order, we'll put it in a queue and then send a response to the user that the order is being processed, and you can later check the order status. So this order process lambda, once all those things are completed, then finally we'll update the status of that order so that UI can, maybe using another request route, get the final status of the order and inform the users. Now this is the application that we are going to add observability into it. And first we will go over the code, and then we will see how can we add observability into our application and then fix any problems related to this architecture. Now, by the way, guys, if you are actually implementing an order processing system, I would recommend replacing this SQS queue with a step function workflow, because step function workflows are ideal to handle different workflows with try catch and error handling and all sort of workflow management activities. All right, so this is the GitHub repository, and I will click code and copy the link, and then in desktop I will create a new directory called my app and git clone into my app. Okay, then I'll open Visual Studio Code, file, open, desktop, my app, and open. Now you can see there's this serverless.yaml file, so we are using serverless framework here. And by the way, if I show you the serverless version that I'm using right now, if I do sls-v, so it's 2.72.3. So let's open the serverless.yaml file. So here we have the serverless service. Let's call it observability demo, and it's using serverless framework version 2. So as for the provider, we are using AWS and the runtime Node.js 12, and these are our functions section. So as for the functions, we have two functions, the order process lambda function and the order receive lambda function. So order receive lambda function is the one that get called by the API gateway as we have seen previously. So have a look. So for this order receive lambda, we have this event configured for API gateway. So whenever a post request get to this path order slash receive, these lambda functions will get invoked. So this is the lambda function that will take the payload and put that order message in SQS queue. So it needs to talk to the SQS queue, and that's why in that environment section I have added the order queue URL. Here we go. I don't need the order table name because in that lambda functions we are not talking to that. So let me take it out. I'll update the GitHub as well. Now we are using infrastructure as code. So we need to create our SQS queue as well. And that's why I have used this resource section, which is purely CloudFormation template, to create this order receive queue. You can see under resources, we have this order receive queue logical name, and that's of type AWS SQS queue. And I'm only adding just one property, that is the queue name. So order receive queue. So here in our order queue URL, I'm using this intrinsic function ref and then point the logical name of our queue so that it will return the queue URL. Now, since this receive order lambda function needs to add that message into the queue, it needs some permission to enqueue any messages into this particular queue. So that's why I'm using this IAM role statement. And here I'm allowing any actions. So I can only add put action here. You can do that. And I'm giving the resource the same queue. So you see, I'm again using another intrinsic function get ATT. Here I have to refer the ARN, so I have to use this get ATT intrinsic function to get the ARN from the queue. Okay, so that's our lambda function number one. And then we have our second lambda function, that is the order process lambda function. Now this lambda function is not getting invoked through our API gateway, but whenever message is enqueued or added into the SQS queue, we will use event source mapping to invoke a lambda functions and consume that message. And that's why the event for this particular lambda function is SQS queue. So here in the event section, it is SQS queue and I have to refer the ARN. So similarly, I'm using get ATT intrinsic function to get the ARN, and I'm defining the bed size as well. So bed size is essentially how many messages are we passing into that particular lambda. So let's say we get simultaneously 10 messages in the queue, but since we have defined the bed size to 1, one by one will be consumed by that lambda function. All right. Then we've added the environment section, and here I am adding another environment variable called order table name, and I'm referencing the order table logical name in my CloudFormation template. So here in the order table, it's nothing but a DynamoDB table. So you can see the type is DynamoDB. And for properties, I am adding the billing mode to pay per request, and then the table name to order table. And I'm defining the key schema or the hash key for this particular table here in this key schema section, and that is the order ID and that is the hash key. And then I will use the attribute definition section to define the attribute type of the order ID. So order ID, it is a string value. So that's why I added order type to S. All right. Now let's have a look at these two lambda function implementation. Now that is available in the handler.js. If you open the handler.js, you will see there are two functions got exported. One is receive order and the order process. Let's expand this receive order function. So the receive order will put that order details into a SQS queue. So that's why I'm first creating an SQS queue instance from AWS SDK. You see, from up here, I'm requiring AWS SDK / client side SQS queue. And by the way, guys, I'm still using AWS SDK version number 2. So if you go to package.json file, you can see I'm using AWS SDK version number 2. And while we are here, I'm also using serverless IAM roles per function to give function-wise permission as you have seen in the serverless.yaml file. Getting back to the handler.js file, So first I require SQSQ and then create an instance of it. And now I pass the event.body where my order details are available. And then I create the parameters required, or the parameter object that is required to send a message to SQSQ. For the message body, I will stringify the body that I receive here. And for the queue URL, I'm referencing the order queue URL that is there in the environment. And then I'll use async await. So I will await SQS to dot send message. And if it is successful, it will return 200 code with the response from this API call. Then let's have a look at the order process lambda very quickly. So order process lambda is nothing but getting invoked by the event source mapper. So whenever message is available in SQSQ, then this order process lambda will invoke, and we will receive only one message because we set the batch size to 1. So here we need to update the status in the DynamoDB table after doing all the order processing stuff. So that's why I have first acquired the DynamoDB document client. See, new DynamoDB document client, and up here I am requiring DynamoDB AWS SDK /client /DynamoDB, and from there I'm newing up a document client. And after that, I will get the message body, and this is stringified. So I will pass the message body, and after that I can do my order processing stuff. It could be like verifying the product details, charging the customer, and maybe finding the delivery partners, and so on and so forth. And finally update the status in the DynamoDB table. And here in the parameters, I am creating this parameter object, including the table name coming from the environment variable and the item. So as you remember, we added order ID as a hash key. So order ID is a must to have attribute, and that is available in my, let's say, body.order ID, and the quantity body.quantity. So let's say these are the only two attributes that we are adding into our order. So order ID and the quantity. And finally, we call document client.put API with the parameters, and we'll await for it. And if there's any errors, it will be catch and then finally it will throw the error. So now let's deploy this. Now I've configured AWS SDK. You can also do so. Then I'll do SLS deploy. Now before doing that, I need to run npm i to install these dependencies. So let's do that. Npm i, then SLS deploy one more time. All right, so it is completed. And as the results, I get the endpoint for the API gateway post method. And let me go and open Postman, and let's create a post request. Now, as for the body, we need to enter the order details. So it should be a row JSON, and let's set a JSON object. Now we need to have order ID because this is our hash key, and it's a string. So let's say it is 100, and then we are also referring to quantity as a number, let's say 10, and I'll go ahead and execute it. And I got a response with the message ID. That means my message has been properly added to the queue. So let's go to AWS console, and I'll go to SQSQ first, and I should see my queue. So this is the queue, and right now there's no any message available. There's no any message in processing as well. So this essentially means our Lambda function has pulled the message and already executed it. And we can actually test that. So let's first go to Lambda. I'll search for observability, and we have these two Lambda functions. Receive one is the one that API gateway invoke, and this is the one that process the order. So let's click the order process Lambda, and here we go. I'll open it up. Can you see it is already connected with SQSQ, which is good. And I'll go to the monitor section, view CloudWatch logs to see if there's any invocation for this particular function. And here we have one log stream for that. Now it seems like it has taken the order ID and the quantity from our message. And now just to check whether it is successfully added to the DynamoDB, let's open the DynamoDB, go to tables, this is the order table, and I'll click explore table item, and here we have the order ID and the quantity, and it is properly added to our order table. Now, do you guys see one thing? Even to track the and check whether it's successful or not, we have to open so many services and logs, and it is time consuming. Now imagine if there's an error. So how do you debug it? Because it's not only related to one service, because these are connected, and in fact these are asynchronous as well. So if it is a synchronous workflow, when we, let's say, invoke this API gateway endpoint, we will get whether it's failed or succeeded. But here I'm only getting some reference. This is properly added to the queue only. So I of course have to go through all these logs and dive deep to find the error. So this is where we need to add a very good observability into our serverless application and easily find the errors and fix them and keep our customers happy. So one of the options that we can directly use from AWS is AWS X-Ray. X-Ray is a good service that we can use for distributed tracing, particularly for serverless, API Gateway, Lambda, and other serverless services. But in this episode, I want to show you another third-party tool that I use in my project, which is really handy when it comes to distributed tracing and finding bugs. And that tool is Lumigo. So a lot of companies use Lumigo for distributed tracing and monitoring. And in fact, they are giving a very generous free tier. So I'll show you how to use this tool and easily track issues in our current architecture. So in Lumigo, I'll go ahead and create a new account. So I'll click Get Started, and then I'll create an account with Google. You will be first asked to add your name and the last name. I'll fill in these details. And then as the second step, I can connect my AWS account with Lumigo. Now we can do it later as well, but this is easier to connect at the beginning. Now here you need to log into your account. So I'll do it off camera. So when you log into your AWS account, you'll be directed to CloudFormation. And there they will point to a CloudFormation template. So we need to execute it. So I'll acknowledge it and create stack. So this is basically creating an IAM role so that Lumigo can use that role to get the information from our AWS account. So let me create it again. All right, so the stack is created. Now if you go to output section, you can see as the output the IAM role ARN here, and Lumigo will automatically fetch that. And as you see, it has already pulled in all my Lambda functions. Now in Lumigo, we can start tracing our Lambda functions. So let's search for our observability to Lambda functions. And here we go. I will select both of these Lambda functions and start auto tracing. So we only have to do auto tracing enabling. And then Lumigo will make sure to track everything related to these Lambda functions, which is useful to us. So we are all set, and I'll go to the Lumigo dashboard. So right now I'm in the function section. I'll click dashboard, and let's see if we see any invocations right now. So we don't see any invocation. It's going to take a little bit of time to populate all the data from the logs. So let's go ahead and invoke the flow a couple of times. So I will issue order number 101 with, let's say, 5 in quantity. That worked. And 102 with, I don't know, 25. All right. So now let's do a couple of refreshes and wait until the log appears. So it's going to take a minute or two. After 2 to 3 minutes, I see the information appearing on the dashboard. Look, we have 4 invocations. So we have invoked the flow 2 times, and our Lambda functions got called 2 times each. So altogether 4 invocations. And there are no any failures, which is good. And there are no any failed functions. And here the most invoked functions, see, we have these 2 functions, the order process and the receive order got invoked 2 times. And the function with most call start. Now this is interesting information. You see, the 50% of these functions are call start. That means we uh, invoke these functions 2 times each, and the first time was a call start. See, and then we can see the associated services latency as well. Now we have this SQSQ and SQSQ, let's say the P95 latency, that is 68 millisecond, and DynamoDB it's 90 millisecond. And we can also see the function durations, how long it took for the first Lambda function to enqueue the message in the queue. P95 is 120 millisecond, and for the order process Lambda, it almost took 500 millisecond to complete the order. And this is the total cost, so it is less than 0.05. So there are no any timeouts, which is, I mean, really good information in this dashboard page itself. Now, there's this issues section. If you go there, we will see any issues related to our Lambda functions. There are no any issues, which is really good. And this is the most interesting section of all. So there is the transactions. So if you click here, you should see the 2 invocations that we have done. This is the very first invocation. The duration that took altogether is 1300 millisecond. And 2 of these Lambda calls are call starts. Very good information. And in fact, I can click on this and I can see this graphically. And here you can see at the left side, we have this diagram. So this is the API gateway that started invoking the Lambda function. Now I can click these Lambda functions and observe what are their return value, what is the event that it received, what about the environment variables, and any other logs as well, which is really good information. See, when I click on here, I can see this Lambda function return 200 status code with this body. So this is the one that we received here. And then this is the event object that this Lambda function received. So as you guys can see, this is the body that it received, the one that we sent over the postman. And if you go to the environment section here, you can find all the environment variable of that Lambda function. Now here I can find the order queue URL that we pass as an environment, and this is the value of it. So it's very informative to trace the request. And then we can click on the SQSQ. So this is the message body we pass from the Lambda function, and the response as well. These are the response headers and this is the response body. And now this is the asynchronous flow. And once the message is in the SQSQ, Lambda functions poll this information and start executing the order. So if you click here, you can see when it polls the information that it received to the body, see records.body, and the environment at that time. And I should see my DynamoDB environment variable as well. And here it is, order table name, that is order table. And then if I finally click on the order table, we will see the information that DynamoDB receive. So this is the table name, the parameters, and that is a successful invocation because we don't see any red color indications in this diagram. And now let's go ahead and simulate some errors so we can identify where the error occurred and how that error propagate in our transaction. So here in my Postman, instead of sending a string value, I will send the numeric value of order ID 105 with item 30 in quantity. And then I'll send the request. Now you see, as usual, I got the response. That means the message got enqueued in the queue. But when I go to the DynamoDB, these are our previous records. And if I do a refresh, I don't see that 105 record. So let's go into our transaction and see if the new transaction is recorded. Yeah, it is recorded. In fact, it's a cold start because we waited a little bit here. And you see there's an issue already identified, the validation exception. So let me click on it. And now I see some red circles in this Lambda function and the DynamoDB. See, there are two red circles. So that indicates two calls. And DynamoDB also indicates two calls got failed. So if I click on the Lambda function, now I immediately see the error. Validation exception, one or more parameter values were invalid, and order ID expected S, but actual it is N or numeric. So that's the error. And if I select the order table also, I see the error, one or more parameters were invalid. Now the interesting thing is, if I keep refreshing this page, I should see more invocations in the same transaction because the transaction is not yet finished. Now see, now this time it's 5 calls. Let me put it in a full screen. Now this time it shows 5 calls. So it's the same transaction. So what's happening there? Now this order process Lambda functions pull a message from the queue and try to process it, and it fails. So the message go back to the queue again. And once that Lambda function is in the queue, after the visibility timeout, this Lambda function again will try to execute the same message. And since there is this issue with the data, it will keep failing. So this goes on and on. See, now it's 9 calls. Now this should stop because this will never succeed because of the data issue. If we go to the SQS queue and do a refresh, you see there's one message in flight always. So what I do is I'll select this queue and go to action and purge this queue. That will take out any in-flight messages as well. I'll purge the queue, and now if I refresh it, there's no any messages. So let's fix this issue. We are going to fix that by introducing a DL queue or dead letter queue. So whenever a queue got a message back to it, and if it is unprocessed, we will put that into a DL queue. So we can later observe the message information. So first let's create the DL queue. So let me just take a copy here of our original queue, and DL queue is nothing but another SQS queue. So this is order receive DL queue. There is also of type SQS queue, and this is order receive DL queue. And from our order receive queue, we should reference this DL queue. So let me go to Google and do a quick search SQS queue CloudFormation. So in the YAML section, what we are looking at is the redrive policy. So this is it. So let me select it. So this redrive policy expects a dead letter target ARN and the maximum receive count. So let's add those two values. In our original queue, I'll add another attribute, redrive policy, dead letter Q ARN, and we'll get the ARN here. So I will use get ATT. So we are giving the ARN of our dead letter Q. And what's the other one? Max receive count. So this is the maximum number of return count of a one message before it's been sent to the DL queue. Well, let's set it to 1. As soon as one message got returned, we'll put it to a DL queue. All right, so let's go ahead and do a redeployment. All right, so it is complete. So let me go to SQS queue and do a refresh. And here we have our DL queue also. Now let's go ahead and invoke the same request with this invalid data. So it was queued, and now if you refresh it, the Lambda function has already picked it up. So There's one message in flight, and let's further refresh. Now that message is no more in flight, and let's do further refresh. And finally, message now in the DL queue. So there's one message available in the DL queue. Now we can select this DL queue, and I can click send and receive message, and we can poll for the message. And this is the message that is landed in the DL queue. And here we go, it's that same message with incorrect data. So 105 is a numeric value, not a string value. And now let's have a look at our transactions. So I'll go to the transaction section one more time. As you see the latest transaction, and see there is also a validation exception, but this time we should not see multiple invocation. So there's only one red invocation, see. As soon as this error occurred in the Lambda function, the message go back to the SQS queue, and then SQS queue will put it into a DL queue. So DL queue is not shown here, but you see now it's already available in the DL queue. So one last thing I want to show you is this system map. So if we select this, we should see the map of all our services and how they interact. See, this API gateway first call the receive lambda, and then it will put it to SQS queue, and this is the order process lambda, poll the messages and put it in the DynamoDB table. And here we can have some view options. Size this by invocations. So if I do that, you see this lambda got invoked quite a bit, because we saw now this got invoked 10-15 times because of that error message in that transaction. So all this information can be nicely visible. If you see errors, again, this has so many errors. So that's why like this is huge. Average duration and all that. Okay guys, so this is what I want to show you. Thanks for watching. I hope this has been useful. I'll see you in another video.